Hello and welcome to this video. My name is Aniruddha, call sign is Victor Uniform number 3, Foxtrot Mike Lima. In one of my last videos, we saw how I made these two components. One is the 49:1 impedance transformer, which is made up of two cores of 240-43 material toroid, and the winding is made like an auto transformer. And the second one is the common mode current choke, is made up of 12 turns of RG316 coaxial cable, and this is the 100 picofarad capacitor. So in the last video we saw the performance of these two components individually. We used nano VNA to check the efficiency of the 49:1 impedance transformer, its SWR response, as well as the attenuation of the common mode current choke in the HF amateur radio bands, and as well as its SWR response. If you have not checked that video, I will put a link in the description. Please do watch it. So using the same components, I have made this unit. So I've put the 49:1 impedance transformer and the common mode current choke in the same unit. Hopefully that should work. We will test it out. It's really a standard make. So here you see an eye bolt for mounting. This is M8 with M8 fasteners. This wing nut is where the antenna element goes, and this is where the counterpoise goes. These are 5 millimeters M5 hardware, and this is the standard SO239 connector where our coaxial would be connected. So we will go outside and install this. I will be using 20 meters or roughly 66 feet of antenna element, and I will attach a counterpoise as well, and then we'll check the SWR response on my rig expert. So stay tuned and we'll get to it. Okay, I have mounted the box over here, and I have also attached the counterpoise. It is about 2 meters in length. That comes out to be 0.05 lambda on the lowest band that I would like to operate, which is 40 meters. And this is the antenna element. It goes to this pole for support, and then it goes all the way down as a sloper to that red shade over there in my neighbor's plot. This antenna element is about 66 feet or 20 meters. So let's go inside and check the SWR response. Okay, so now let's check the SWR response of this antenna. I have selected 15 megahertz as the center frequency and then 14 megahertz as plus or minus range. Let's just do a sweep. The vertical blue colored bars represents the HF bands, and here you can see that the curve shows dips in the correct bands, but this won't give us the precise readings. We can go to individual bands and then check there. So this is the 40 meter band. Looks like it starts at 1.5 and then goes to about 2.5 at the upper end of the band. In 40 meter band I operate mostly near 7050 or thereabouts. That's where maximum traffic is here in India. So 7050, it says it is 1.57. Not bad. Let's change the band and go to 20 meters and start. So the best SWR is 1.26 at 14.320. I operate mostly at 14200 to 14220. So at 14200 it is 1.33, and at 14220 it is 1.31, and if I go higher the SWR improves. So not bad at all in 20 meter, 1.3 or thereabout. Let's go to the 15 meter and do a sweep. Starts at about 2.5 and goes a little below 2. So the best is 1.96 at 21.470. I do not have a preferred frequency range where I operate, but you can say that it is about 2 in the second half. The SWR is about 2 in the second half of this band. Let's go to the 10 meter and then do a sweep. This also seems to be better in the second half. It's going between 2 to 1.57 in the second half of the band. So overall, it seems to be doing good. I can always use my LDG Z11 Pro 2 auto tuner to touch up these frequencies and operate. I may go ahead and do a little bit of more tuning, but right now this is all for this video. I hope you like this content. If you do, please press that subscribe button and also press the like button. Until next time, 73 is from Victor Uniform number 3 Foxtrot Mike Lima. Cheers.